Welcome. In this lesson, you will learn about the software interfaces. You will also get an idea on setting up for model exchange and co-simulation. No product in the world can do all things and answer very well all needs. That's why SimCenter MCM is open to other tools. There are also kinds of third-party software from various fields of the simulation domain that can be coupled to SimCenter MCM. FMI interfaces. The FMI standards define two kinds of interfaces. Model exchange, which describes a standardized way for interfacing a model, packaged as an FMU. Co-simulation, which deals with the coupling of complete simulators. Simulink interfaces. Model exchange. Export from SimCenter MCM to Simulink as function. A Simulink integrator is used for the entire system. A Simulink model can be combined as a SimCenter MCM model and solved using SimCenter MCM integrator. Co-simulation. A co-simulation can be performed both as slave or master. Multi-body interfaces. We take motion as an example. The interfaces of SimCenter MCM and motion also allow user to perform model exchange and co-simulation. We can take advantage of the strengths of both the two software. CFD interfaces. SimCenter MCM now supports a significant number of CFD software packages. The exchange of data between SimCenter MCM and the CFD tool is done through TCP or IP components, or user cosim generic interface. Step 1. SimPlant, FMI for Co-simulation 1.0. In this lesson, we will take FMI interfaces for example to show how to perform model exchange and co-simulation. Launch the steamplant.m file. This is a simple model of a steam power plant. The heater and the mechanical load are to be modeled outside of this model, and a co-simulation is set up to simulate the whole coupled model. The model has two input variables and one output variable. The heat flow rate produced by the heater is an input of the model. The rotary speed of the turbine shaft is an input of the model. The torque applied by the turbine on its shaft is an output of the model. These input and output variables are connected to a functional mockup interfaces for co-simulation block. Right-clicking on this block icon and choosing the Edit Interface icon. The interface icon creation dialog box that summarizes the variables that are to be exchanged during co-simulation. Nothing has to be changed in this dialog box. Quit it by clicking the Cancel button. Go to simulation mode. There is a reminder to add libraries to the path list. Click Yes to move on. Pull down the interfaces. FMU Export Assistant manual command. It starts the first step of the assistant. In the drop-down list, select Co-simulation 1.0 for the FMU type and version. Select the High Visibility Level option and leave the Embedded Tables checkbox selected. Finally, type in the path to the working directory. Click the Next button to proceed to the second step of the assistant. Select the architecture and compiler combination corresponding to the platform and press the Generate button. Here, we select GUN/GCC. The last step of the assistant reports that the FMU is successfully created. It can be checked that a slave functional mockup unit for co-simulation called steamplant.fmu exists in the same work directory as the SimCenter MCM model. Save and close the model. Step 2. Speed control. FMI for Model Exchange 2.0. Launch the speedcontrol.m file. Go to simulation mode. Pull down the interfaces, FMU Export Assistant manual command. This starts the first step of Export Assistant. Select Model Exchange 2.0 for the FMU type and version, and the High Visibility Level option. Leave the Embed Tables checkbox selected, and type in the path to the working directory. Click the Next button to proceed to the second step. Select the architecture and the compiler combination corresponding to the platform and click the Generate button. The last step of the assistant reports that an FMU called speedcontrol.fmu is generated. Save and close the model. Step 3. Full model of a Steam plant. Launch plant load control ass.m file. The SimCenter MSIM model restricts to the mechanics part of the system. We need to import the speed control loop and the steam power plant loop to finish the modeling. Import the two FMU. Open the interfaces, FMU import assistant menu command to open the FMU import assistant dialog box. Type the path to the FMU to be imported, or click the button to choose the speedcontrol.fmu. Then type in or choose the path to the directory in which the import submodel is to be generated. And select the checkbox close to the submodel name to let the assistant automatically assign a name to the import submodel. Click the Next button to proceed to the next step. At this step, the compilers available for the platform are displayed. You have to choose the same combination of platform and compiler as used for generating the two FMUs. Click the Generate button to enter the last step. Click the Finish button to quit the assistant. The path to the submodel storage directory specified at the first step is then automatically added to the category path list. Reopen the FMU Import Assistant and proceed through the same steps to import the steam plant.fmu. Using the two FMU, drag and drop the speed control and the steam power plant loop to the corresponding position. The complete circuit is built. The model of the steam production loop is contained in the slave FMU for co-simulation file called steamplant.fmu. The model of servo mechanism, along with the heater actuator, is contained in an FMU for model exchange file called speedcontrol.fmu. Move to simulation mode. After the compilation finished, modify the final time to 10 seconds. Click OK and run the simulation. Post-process the simulation results using the plot configurations or run on the dashboard. The variables exposed by the two FMU are available for all the post-processing facilities of SimCenter MSIM.